Hey everybody, this is Doug. Let's talk about magnets and airport security, venue security, store security, stuff like that. Every couple of weeks, somebody posts a video on one of the Facebook pages that I'm watching that mentions either magnets or airport security or going to a concert or something to that effect. And they ask, is it safe to walk through security, or what happens if I come into contact with a magnet? And the responses that we typically see range from it's totally safe to don't do it, you'll die. And that's not really an exaggeration. There's a wide range of responses in between those two extremes. Now, obviously, they all can't be right. There's got to be a correct answer in there. And what's interesting is that in the history of our devices, each of those answers was at one time correct. So what I thought I'd do is I'd give a little history about our devices and why it was really unsafe for us to walk through airport security or be in close contact with magnets at one time, and how that's changed over the years. Now, how do I know this? Who am I? Well, I'm a device patient. I have an ICD. I've had one for 3 years. But I also worked at Medtronic for 14 years, and I don't work there now, so I'm not speaking on behalf of the company or anything like that. But I did work at Medtronic 14 years. I worked at 9 years in the cardiac division and 4 years in the quality group at the cardiac division. So I've learned quite a bit of things over time, and I've asked a lot of questions, especially after I got my device. So I've done a lot of research on this, and I think I have the facts pretty well straight. Still yet, I'm not a medical professional. The interesting thing is that the truth is that doctors and nurses aren't exactly the best resource for this kind of answer. If you have questions about the things that I'm talking about, I encourage you to call your patient services group at the medical device company of your device and ask them questions. They're the ones that will know this. They're the ones who design these devices and test them. But really, in order to understand what has changed over the years, you kind of need to understand what happens to our devices or with our devices when they come into contact with a magnet or a magnetic field. What used to happen, 20 or 30 years ago is actually very much the same as what happens now. Some things are different, like now some devices have wireless capabilities. So when you put a magnet over your device, it turns on the wireless option. So wireless transmissions can happen. So that's new. But really the important things that matter to us patients, those haven't really changed over the years. And I'm going to be talking mainly about Medtronic devices because that's what I know about. But most companies mimic these same actions, or they can be programmed to do the same thing. So if you have another company's device and you're curious how your device reacts with magnets, call your patient services group. They'll be able to help you out. But basically, first of all, our devices are designed to interact safely with magnets. Can you imagine the lawsuits that would come about if something as simple as a child's toy or the clasp on a purse could do something harmful to our device? The lawsuits would be incredible. So our devices have been designed to interact safely with magnets. Patients just need to be aware of what happens when a magnet comes close to our device. For Medtronic pacemakers and CRTP devices, when you place a magnet on top of the device, all that happens is it switches programming from whatever your doctor programmed your device to do now. It switches it to a constant rate of 85 beats a minute 100% of the time. So it will pace you 100% of the time at 85 beats a minute until you move the magnet away. And then it'll switch back to the programming that your doctor programmed for your device, either at implant or at your last device check. Pacemakers don't make any noise when they come into contact with a magnet, so they're just not built with a speaker that makes noise. So you won't know it other than you might feel the change in pacing. So it doesn't scramble your programming. It doesn't turn off your device. It doesn't stop pacing. It will switch it from whatever it's doing right now to 100% pacing at 85 beats a minute. And then when you take the magnet away from the device or you move out of the magnetic field, it switches back to the other programming. And no harm will come to the device during that interaction. With ICDs and CRTDs, it's a little different. Pacing isn't impacted at all. It doesn't change pacing at all. What happens when you put a magnet on a Medtronic ICD or CRTD is, first of all, you'll hear a tone. And 99% of the time, it will be a solid 10-second tone. In the rare occasion that you hear either that truck backing up or the French police car, that's when you should call your doctor. That means an alert has been tripped. But 99% of the time when we come into contact with a magnet by accident or just in our everyday lives, you're going to hear that solid 10-second tone. That's a good warning for us. It can only happen when it comes into contact with a magnet, so that's a really good warning for us. It's kind of an indicator that we're a little close to a magnet. But when you put a magnet on an ICD or CRTD, it inhibits detections. That's the technical term. It inhibits the device's ability to detect a fatal rhythm. In other words, you're putting blinders on your device, and if your device can't see a fatal rhythm, it won't shock you. Now, this is intentional. This is not an accident. This was an intentional design, and it was designed for surgeons because surgeons like to use a scalpel that has a tip that has electricity that runs through it. It's called electrocautery. As it cuts the skin, it cauterizes, and it causes problems with devices sometimes. It tricks devices into thinking there's a fatal rhythm. So imagine you're in the middle of a surgery, there's a surgeon with a scalpel on your chest, and your device thinks you have a fatal rhythm, and it shocks you and you jolt. Bad idea. So during a surgery, the surgeons will hook you up to an external defibrillator and monitoring system, and then they'll put a magnet on your device, and it looks like this. Medtronic makes these. They'll put this on your chest, and it will inhibit detections. It will prevent your device from seeing any fatal rhythms or any suspected fatal rhythms, and it will prevent your device from shocking. That's all it does. It doesn't scramble programming. It does nothing to pacing. It doesn't induce a shock. It just, while the magnet is on top of your device, it will prevent your device from shocking. So that's what magnets and magnetic fields do to our devices. They either switch it in a pacemaker to 85 beats a minute, or in an ICD, they inhibit detections and prevent a shock from happening. So the mechanism by which that happens, though, is a little different. And that's changed over time. And that's where I think the confusion of what's safe for us to do as patients, I think that's where it came from. And so let me tell you a little bit of the history, and maybe it'll help you understand why things have changed in the last 20 years. Way back when, all medical device companies made their devices with a little electrical feature, a little electrical circuit called a reed switch. Now, this is a very common electrical electrical feature, and it's often activated by magnets. So it's much smaller than what I'm going to show you, but basically what it is it's a tube, and I don't remember if it's a vacuum tube, but it is sealed, and it has two little metal prongs in it. And when your device comes into contact with a magnetic field, those prongs magnetize north and south pole, and they attract, and so they close a circuit, and that causes your device to enact whatever procedure it's supposed to do next. With pacemakers, it goes to 85 beats a minute. With ICDs, it inhibits detections. And when you leave the magnetic field, those poles demagnetize and they spring back apart. And again, this is a really tiny piece of equipment. I think the prongs are smaller than the lead of a mechanical pencil. So it's a really small thing. The problem that started to occur, though, years ago, was that those seals or those little tubes would crack, and moisture would seep in, and the moisture would condense around the reed switch and around the little metal prongs. And so when it came into contact with the magnetic field, they would contract, they would come together, and it would make the device switch modes. And then when you left the magnetic field, that moisture would keep that switch together. And this caused a lot of problems. Now, in pacemaker patients, your device is going off at 85 beats a minute 100% of the time. You might notice this during the day, but you'll really notice it when you're trying to fall asleep and your heart rate won't drop below 85 beats a minute. Or when you're trying to exercise and your heart rate won't go above 85 beats a minute. So pacemaker patients would feel like crap, and they'd go see their doctor, and the doctor would analyze the device, and either through experience or through talking with the company tech would figure out that this reed switch was stuck. Unfortunately, the only way to fix a stuck reed switch is to replace the whole device. And while that sucks for a pacemaker patient, it's not deadly. It's not lethal. The same is not true for ICD patients. When that reed switch sticks, your device, it's inhibiting detections. And if it never separates, the patient would never know. Actually, the only way they would ever know is if they have a cardiac arrest and their device doesn't work. So that was a serious problem. Every company used reed switches. Every company had failures, both in pacemaker and ICD patients. And unfortunately, some patients did die because of this issue. So industry knew they had to make a change, but those changes couldn't happen right away. And in fact, even when devices were available that were now redesigned, the industry didn't go out and change all the devices that were there because the risk of changing the device was actually higher than the risk of the reed switch problem happening at all. Infection risk was higher than the rate of incidence of this reed switch problem. So patients just kind of had to wait until their device came to end of life and then get switched out to a new device. So the medical device companies stopped using reed switches and they started using something called a Hall sensor, H-A-L-L, a Hall sensor. And that's an electrical sensor that just is sensing a magnetic field. So when your device comes into contact with a magnetic field, it senses that and says, okay, now I need to switch modes, and it does it electronically. There's no mechanical switch that operates that. The change over to Hall sensors happened over a decade ago, or started over a decade ago. And I don't know where each company is in the process. I'm pretty sure no company uses reed switches anymore, but I know for a fact that Medtronic stopped using them 10 years ago. So if you have a new implant or a replacement device within the last 10 years, you definitely do not have reed switches in your body anymore. So, one thing that happened while they were fixing this issue is that they went out to physicians and said, here's this problem that we're having. These reed switches are sticking. This is, annoying in pacemaker patients, but potentially fatal in ICD patients. And so the word kind of went out, avoid airport security, avoid magnets. They're dangerous. And in a sense, they were correct in that sense that if you had that reed switch problem, it could be fatal for ICD patients. So that word went out. Unfortunately, it took a long time. It took a few years to get the new devices out with Hall sensors. And then it took even longer for all those old devices to just come to end of life and be switched out. And so there really wasn't a huge push to say, okay, now it's safe. You can tell your patients this. Physicians have learned over time that devices are now safe to go through airport security scanners and venue concerts and baseball games and things like that. But there are still some accounts, there are still some centers that either they've been around for a really long time, or the training that took place when they switched from someone older to someone newer didn't include this new information. So, the problem that the reason why people were told not to go through airport securities was because the reed switch could stick. That problem doesn't exist anymore because devices don't have reed switches. They have Hall sensors now. So that's a big one. The other one is that there's now an international standard for how strong a magnet needs to be to trigger some kind of response in medical devices. And that's 10 Gauss. And that's actually a fairly strong magnet, and it needs to be directly on top of the device. To kind of give you an idea of how strong something would need to be, this one that Medtronic gives out to hospitals, this is 90 Gauss. So it's 9 times stronger than what it needs to be. And here I'll show you how close it needs to be to actually activate. You'll hear it, it'll tone the solid tone. So let me see how close I can get it to my chest here before it happens. Here's my device. See right there? So I'll let that run out. That's about 3 inches, 3.5 inches. Let's call it 4. So 90 Gauss, a really strong magnet, 4 inches above my skin. That's what it takes to activate the magnet response in my device. Now, right now, I got this strong magnet on my device. Again, it's not harming anything. It's not hurting anything. All it has done is it has forced my device to inhibit detections, so it will not see a fatal rhythm if it happens right now, which means right now I'm not protected. But as soon as I do this, I take the magnet off my chest and I move it away from my device, that switches back to its original programming and everything's working normally again. So when you talk about airport security and could it trigger, first of all, Can it be dangerous to us? The answer is no, because the problem that existed that caused that problem, reed switches, no longer exist inside our devices. Also, it takes a pretty strong amount of energy to trigger a magnet response, which the archway just doesn't generate. But if you ask an engineer, so what you're saying is it's impossible? They'll say, well, it's not impossible, it's just really, really, really unlikely. They'll never give you a 100% answer of no, it's not possible. So how do you mitigate that? How do you make that even less possible? Well, what companies like Medtronic have done is they've instructed their patients to walk through the archway at a normal pace. So even if it does trigger a magnet response, it's momentary. It's as you pass through the gate, it would activate and then deactivate as soon as you walk through the gate. What that would mean for a pacemaker patient is maybe they might get an extra heartbeat as the device switches to 85 beats a minute and then switches back to its normal programming. For an ICD patient, a CRTD patient, it means you would have detections inhibited for like that quick. As you walk through, it would inhibit detections and then turn that off as soon as you walk through the gate. So is that dangerous? Not at all. And again, it most likely won't even trigger anything as you walk through the gate. Now, at airport security, they also have the millimeter wave scanners. That's a different kind of technology. It doesn't use magnets, so that's really not a concern at all. And then you have the wands. Now, the wands are kind of like the archway. They're looking for metal. And, again, they're not going to, there's no way they can scramble your programming or change it or turn off your device. Again, at best, it could trigger that magnet detection, and it would only be active while the wand is directly over your device. Remember, again, I was holding this 3 inches from my device. So if they're waving a wand in front of you, if they trigger that magnet response, it will be momentary. The only thing that companies suggest is you don't let it wave over and over the device. And I had to ask, why was that even an issue? And what I found out is that if you wave the device very rhythmically over, or if you wave the wand very rhythmically over the device, a lot, like 7 to 10 or more times, and you're in sync with your heartbeat when you do it, you could trick your device into thinking that there's a rhythm. So when they say don't wave it over, don't let them wave it over your device, that's what they mean. If it goes over 3 or 4 times, that is not a problem at all. Nothing's going to happen. And again, at the very, very worst, what could happen is it will trigger that magnet response momentarily just while the wand is over the device. So, that's the same with going through at concerts, at ball games, just, security in general. People ask what I do personally when I go to the airport. I never mention that I have a device. I put my things on the conveyor belt, I send it through, I walk through the archway. I've never had a problem at the airport. The only time I've ever had a problem was at a courthouse. And the sensor went off, and so I went back and I emptied my pockets again and I walked through again, and it went off again. And I told the guy, well, I do have a medical device. He says, oh, ours is really sensitive. We sometimes pick up knees and pacemakers and things like that. So he wanted me, and I was on my way. The last one that people talk about is store security. So the pylons, like at Walmart or Target or Best Buy, those are RFID technology. They're looking for RFID tags that are embedded in the boxes and attached to clothing and things like that. The RFID technology doesn't interact with our devices at all. Again, you can't scramble your device, you can't change the programming, anything like that. It's just not the same technology. It's kind of like saying you can't run your microwave while watching TV because it'll mess up the TV waves. It doesn't happen. It's not the same technology. At worst, what can happen is that sometimes the RFID waves bounce off our device and get triggered by the pylons. So I have heard people talk about how they sometimes set off security as they're walking through. It shouldn't happen, but I guess it's possible. So that's really it. You got to be aware of what magnets do to your device. Again, with pacemakers, it switches it to a constant rate. And with ICDs, it inhibits detections, so it won't see a fatal rhythm. And that means that we have to be a little bit careful. So, you don't want to fall asleep with an iPad on your chest if it's got a magnetic cover. People have magnetic wrist watches. Well, you don't want to wear that in case you fall asleep with your arm across your chest. Yeah, that's not exactly safe. But if you come in contact with a magnet, it's no harm to your device at all. None at all. and you don't need to contact your doctor about that. You don't need to send in a download or go to the ER if you hear that 10-second solid tone. Actually, what most people don't know is that for Medtronic devices, that 10-second solid tone actually is an all clear. If you were to come in contact with a magnet and you hear a truck backing up or a French police car, that means an alert has been triggered and you should contact your doctor for that. But if you accidentally come into contact with a magnet and you hear that 10-second solid tone, you should think two things. One is, well, I'm somewhere close to a magnet, let me find that and move it so that it's not close to my device anymore. But also, hey, that 10-second solid tone, that means no alerts have been triggered, my device is working great, so that's a good thing. It's kind of a reassuring thing to say, hey, your device is working fine. So that's really it. I hope that a little history lesson with talking about reed switches and hall sensors and airport security, kind of the evolution of our devices, hope that helps people out a little bit. I hate to see people avoid doing fun things in life like traveling when they think that airport travel in general is unsafe, because nowadays it's just not. Again, if you have any questions about this, really the best place to go is your device manufacturer. Call your patient services group, and if for some reason they don't seem to be giving you the straight answer that you think you need to get, ask to speak to the technical services group. Now, these are often engineers, and they're really good, and they will answer any questions you might have for them. So hope that was helpful. I hope that was helpful, and I hope you all have a great day. Thanks.